Hello everyone, my name is Arkan, and in this video I'm gonna show you my ultimate data engineering project. So why it's called ultimate? Because it's cover almost all of common data engineering concepts such as stream processing, batch processing, CDC or capture data chains, data lake and data warehouse that combine into data lakehouse, and there is also query optimization, and there is also machine learning, and then we have Spark here, and like Windows function concept, and there is also SQL and Python, of course, and finally there is a data visualization. um okay, so in this project, the study case that I take is an automotive manufacturing factory, because many of Chinese automotive manufacture is open in here in Indonesia. So okay, here the case is the manufacturing plants face two primary challenges, which is first is unexpected machine failure, and the second one is silent data system. So I built this pipeline for the solution. So for the unexpected machine failure, we can monitor the data from the IoT sensor from the machine, and then uh, predict predict it with the machine learning. And yeah, well, we are monitoring uh, the machine. Is it like, is there any potential issue to uh, machine failure or not, so that can uh, you know impact for cost efficiency for not to buy the new machine. And for the silent data system, so there is a supply chain data that start in legacy database here using Postgre, and there is a CRM data that start in CRM system here in uh, Google Sheet. And for the uh, supply chain, I'm using CDC, and for the CRM, I'm using batch pipeline. So without further ado, let's get into the demo. So here I'm using a Docker container, Docker all lot of Docker container that start on in Docker Compose. So to run this, you can use first of all clone this repository and set up credential, such as like here there is a Git ID, the link into your Git, and run all of the container, which is Docker Compose profile default up dash D. Because I have limited resource, and my device cannot run all of the services, I create the profile for each pipeline. So there is four like section or pipeline. So here is the stream processing. There is also a CDC. There is a batch processing, and there is a lakehouse. So the stream processing basically here the monitoring. So and the CDC is here in to detect supply chain, and the batch processing is for CRM, and the data the lakehouse is, yeah, the data lakehouse itself. So first of all, we can run the Docker compose dash dash profile, maybe the stream first, stream processing dash d, and yep, the container is run. So for the stream processing, this include the IoT. So here I'm using the data generator to mimic the IoT sensor, and there is also Kafka and Zookeeper to so there is uh, to stream the data into Fling. So here there is four topic. So each topic is for one machine. And here in Fling there is several job. So this for job is transform the data from the Kafka into the and transform it, like predict using the machine learning model, and store it into the uh, ClickHouse, and then visualize it, visualize it using superset. And the other job, the other four, is to transform it to into a ParQ file that can so that can be stored in Data Lakehouse. So there is stored on ClickHouse for monitoring, and there is also stored uh, in Data Lakehouse for maybe for the analyzing and for the model development also. So yeah, let's see here. Okay, so the data, where's the IT sensor data generator? Yeah, so it generates the data, and then there is go to Kafka, and then here go to Flick job, which is transform into ClickHouse and to Minayo. So here, for example, to ClickHouse, basically it's okay. Basically, it's get the data from the Kafka, and the topic is arm robot machine sensor, and here's the properties. That is the Kafka server, and the serialization schema, which is the input schema. We define the input schema here. So here the function is to serialize uh, JSON format. So after get the data, we load the model. Okay, so here, so this is the just the JDBC connection setup for the ClickHouse. So here there is a ClickHouse URL. So the port is 80.123, and database is named stream data warehouse, and the password and the username is admin, and here's the sync is insert into blah 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 blah. So first of all, uh, we are going to load the model, the machine learning model, and then from the uh, get data is go to the transform data, and the input is sensor data from the Kafka and the model. And then here from the transform data, here we are going to reprocessing it first, like you know processing it first, like yeah, here just enrich the data, like enrich the data, and yeah, so here we define if there is a missing feature or not. So yeah, this like a null preferential step. And after the pre-process the data, we predict the data using the model, and if the failure prop is lower than 0 0.3, then the risk level is low. But if the failure is between 0 0.3 and 0 0.7, then the risk level is medium. And if you know, between uh, if greater than 0 0.7, then the risk level is high, so that the machine needs to be maintenance. And here return the date time, machine ID, machine type. Yeah, so what is the type, what is the ID, and what is the failure probability, and there is a risk level also. And yep, if the data is transformed, load it into the ClickHouse. And there is also the to Minayo, yeah, it's same, but the difference is, the transformation is about change the data format from the JSON into the parquet to optimize the storage space. Yep, I think that's it. And here there is also a batch size, because we buffer the write to Minayo sync. The example is 10 data, so each parquet file contain 10 data. And yeah, okay, oops we will see the host. So the password is, the username is Minayo admin, also the password is same, Minayo admin. So here on Data Lake, there is a sensor data that contain four um, machine type. So there's a robot, there's you know today today's date, and yeah, here there's a parquet file, and each parquet file contain 10 data, for example. And yep, okay, so here there is a, the model is stored here, and the warehouse, yeah, it's for Data Lakehouse. Later I will explain. Okay, so what else? Okay, so when the data also start on ClickHouse, so going to here, if you can see this on the left, there is a here ClickHouse. Okay, ClickHouse is loading. Just wait for the connection. Okay, okay, okay. So here there is a stream data warehouse uh, database. On the database, there is a table called sensor data. And if we see the data, it seems like in here, yep, prediction timestamp, machine ID, machine type, yeah, same. And we see the data, okay, too many rows. Maybe we are going to, you know, select count. Oh, there is a 419. So maybe we just select, limit the, you know, limit the data, maybe like 100. Okay, so okay, so here there is a timestamp, machine ID, the machine type, and filer probability, and also there is level. Okay, see, okay, from here we can also see the, is there any, okay, so here for example, the special assembly with the machine ID beta SM, yeah, whatever is this, needs to, you know needs attention, like, is it uh, here there is a high, so injection molding, there is a high risk level, so this need attention to, immediately uh, do the maintenance, because this machine has a high risk level to failure. Okay, and oh yeah, I forgot the to define the click house. So here, when the click house is defined, is when the click house container is run, it's immediately running the, create running this query, the init SQL query, and immediately running the create the database called stream data warehouse and create table. Here I'm using engine merge tree and order by prediction, timestamp, machine learning, and machine ID to, indexing. And here I also create the projection to optimize the query ladder, because in uh, in the click house we are going to, monitoring the how many, is there any like machine that have high level risk failure or medium. And so to, to get a query fast, I add the projection here. So projection basically it's like a materialized view, so to it, when the new data arrive, it's automatically count into the projection. So it's, like, it's oh it's uh, done already to count. So when I, when query these things, uh, the click house is no need to, you know get a long time to query it. And here I'm using also materialized projection, yeah, just in case there is data get inserted before the projection made. And here I'm using optimize the table to, yeah, if I want to query this query, uh, the click host automatically get the data from projection, not from the table, the main table. Okay, so that's also the uh, query optimization. And it's also, visualize, you can also visualize the data, the monitor the data via superset. Okay, I think that's it for stream processing. Okay, just docker down stream processing first, and we are going to the second uh, profile, which is CDC, change data capture. So here, let me clear the volume first. Okay, and here we are going to the second profile, which is PostScript. Is it recording or not? Yeah, it's recording. So yeah, let's run the docker compose dash dash profile cdc up dash d. So it's contain Postgre, Debizium, Kafka, Fling, and Ops. Okay, okay, let's see the main first. Main admin. Okay, so okay, so the data lake is still empty. Yep, and here on Postgre, we check on Postgre. On DB system, there is database called DB system. There is a public schema, and there is a logistic um, data. So here view data. Okay, so it's still empty. So when I, you know, insert the data, okay, here for example, I insert like 200. If I'm not wrong, it is like 200 data. Okay, so here in database refresh. Okay, so the data is inserted to logistics table, and the the division should uh, detect the table changes and set it into Kafka, transform it into Fling, transform it into Fling, like um, yeah, here into Fling. Yeah, so in Fling we transform the division message, so there is a status here, and is delete or is update or is created. And we also turn the file format into the parquet file. Yep, so same logic as the stream processing. And yeah, here in the batch size is 100, so each parquet file contain 100 data. So let's refresh the data lake. So here there is a logistic date, yeah, the date right now, and there is two file because we inserted the 200 file, which is, and each file contain 100 data. Its parquet file contain 100 data, so there is a two file here. Okay, that's it. And okay, when I change the stock here, yeah, the Visium also, you know the Visium also detect the update and transform in Fling. There is here there is script is update, and here we can in either in Data Lakehouse we can just upsert the uh, data, so there is no duplicate data. So yeah, oh yeah, on um, so well create the Debizium. So here the Debizium connector is created automatically because I have set this uh, Docker. So when the when the Debizium container is running, this container is run to create the Debizium connection from the uh, PostgreSQL. So yeah, here is we wait for the Debizium and then Debizium is ready. Just curl this Debizium connector. Application type. Okay, so the container setting is here on Debizium connector. So on Debizium connector Postgre connector.json. So here the connector. The name of the connector is Postgres dash source dash connector. So here the the rest config. There is a class, plugin, database, hostname, which is Postgres, the port, user and password, the prefix, and database name, which is database underscore system, and the database server name, Postgres, and table public dot logistic. So here the table schema. Yeah, that's it. So yeah, the resume detect the uh, change data in Postgres, stream it into Kafka, transform it to Flink, and load it into main.io, which is on Data Lakehouse rather, main.io as a RQ file. Okay, I think that's it for the CDC. Okay, let's take down first, and let's clear the volume. Okay, and the third one is uh, yeah, let me close this first. Okay, so the, the third one is like on CRM. So batch processing from CRM, trigger with airflow, schedule with airflow, yeah, into the main.io. So here is my, you know, log issue data. Okay, so here is my Python operator. So here's the deck, and here is okay. So there is just one deck, one one operator, which is load data from gsheet. So here's the function. So we load the data from this uh, gsheet. So there is a gsheet ID here. Okay, maybe just sheet, not maybe just copy this and change the gsheet ID with this. Okay, is there any, is there something wrong? Hmm. Okay, maybe let's. Okay, okay. So yeah, here is the uh, gsheet ID. I don't know what. Oh, maybe there is some URL that I not filled. So yeah, anyway, here's the digit ID. So just copy it, hit the this code into this digit ID. So it's still the same, I think. And yeah, here's the CRM source data. So there is like 50, yeah, 50 data, and you want to save it into the data lakehouse. Okay, so okay, I forget to I forget to start the Docker. Volume is clear. Okay, okay, my bad. I forget to start the Docker compose. Uh, Profile. Oops. Profile. Uh, what is called batch processing, I guess. Dash D. Okay, it's correct. Okay, so basically it's just get the data from this CRM, and don't forget to filter the uh, the date to same as like today's date. Okay, so okay, so maybe we are going to today. Okay, we are going to modify this first. Go to today. Okay. Okay, so here's the main IO. In IO admin. Okay, so there is a empty data lake. Okay, and you will see uh, the airflow UI admin. So here there is a Kishitsu main IO deck. Yeah, so basically it's just run the deck, trigger the deck first. So deck is like I said before, run this Python operator, which is easy to main.io, and from this function plot digit data. First of all, yeah, just uh, you know get the data from the digit, iterate by the date now, and convert it into parquet and upload it into uh, main.io bucket. So okay, when the data is run successfully, we check the data lake, refresh, there is a CRM data. Okay, so this is the parquet file for CRM data for batch processing. So I think that's it. Okay, yeah. Okay, let's take it down first. And the last one is the data lakehouse. So let me tidy up this first. So the data lakehouse is contain main.io as a S3 storage, the Spark as a transformation tools, Airflow for scheduling, and orchestrator, and there's an iceberg. It's like table format from the archive file that stored on main.io, and there is also an NC catalog. That's the NC basically is like you know GitHub version of the iceberg table. Yeah, so we use the NC catalog, and there's a Trino, the query engine to query the iceberg table. So yeah, let's see. Okay, let's clean the volume first, and let's run the docker compose dash dash profile lakehouse up dash d. So it's creating the required container to create the um, lakehouse. So yeah, uh, like when the stream processing it's produce the perq, cdc also produce the perq file, and the crm batch processing produce the store the perq file on minio s3. And um, you know I just copy the data here. There is a crm data, there is a logistic data, and there is a sensor data that we can use to you know like pretend to like stored data from this uh, tree pipeline. Okay, okay, it works. Oh yeah, I forget to mention uh, I have this mc docker container here. Where's the mc? So the mc is automate uh, the Minayo to make a bucket. So here there is a set the Minayo and into Minayo admin. Yeah, it's the user and password. Set the alias, and here make bucket or create the bucket called Minayo warehouse, min data lake, and model. And set public, yeah, set the policy to public for the every bucket, and copy, yeah, the model is copy from the models. Copy for Mine.io for the models. Where is the models? Yeah, the models is from the IM machine learning and model. Yeah, here machine learning models that I trained before. So let's continue. Okay, let's um okay. So login first into the Minayo admin. So here's there's empty data lake, insert data. Okay, so we have insert the data. Here maybe also login into the airflow. We also open the spark. Okay, so uh, when the docker is when the minayo is created, and the uh, Messi is created, the, there is a Spark job that automatically run called um, Spark submitter. So here, this is a job to init the Lakehouse, which is here in Lakehouse, which is create the table structure of the Messi catalog or iceberg. So here, create namespace Messi catalog, create the catalog first, and create the empty data frame, and define the uh, schema, define the structure of the table, and then yeah, create the data frame with empty data and write it into the with for iceberg format into the NESI catalog, arm, uh, arm robot sensor, and yeah, it's depends on the machine, because is uh, each machine contain different field. So yeah, when it's finished in NESI, localhost 1990. Okay, it remain there is a NESI catalog that built here. Okay, create namespace NESI catalog, and inside the NESI catalog there is a for table, which is, you know, arm robot sensor, battery assembly machine sensor, CNC machine sensor, and injection molding machine sensor. So this, okay, so this for table great for to store the, you know, the for each machine sensor. So to and to, you know, here in data warehouse there is nice catalog, there is there is also the metadata, and but when we see in, just close it first, Lakehouse, NESI catalog, there is for table, and we will see view table. Okay, the data is uh, still empty because we are not uh, run insert the data, uh, because we are not inserted the data first yet. So what we are going to do is using uh, Airflow to schedule the Spark job to upsert into the uh, from the queue into the table format, Spark table format. So let me give this example, upsert into iceberg robot. So basically it's, you know, run the queue file, and run the queue file from the date. Here I set the yesterday date, if not, you know, specifically mentioned on the uh, argument here, and just you know, I'm using also here the Windows function to uh, to count the moving average for temperature in six from six record before. Yeah, so here I'm create the moving average temperature Celsius, that called average temperature Celsius from the this Windows moving average. And here I'm create the replace temp view, called staging data, and here I'm using Spark SQL that merged into NESI catalog, robot sensor as a target, and using staging data here, this df data frame as a source. And yeah, well, when the timestamp and machine ID is same, then the data is which means the data is duplicate, right? So we we don't wanna the duplicate data, so we update, instead we update the existing data. But when there is no match, which means it's you know, new data, then we insert the data. Okay, so here's the deck. So here's there is a Spark config here, and yeah, there's a jar here. So there is a four tasks here. There is upsert into, you know, each machine type. And here I'm using the sequence because it's because uh, my limited resource. But if you have a lot of resource, you can run the task into these four tasks into a parallel. So yeah, let's demo this. Okay, trigger deck. Let's see if okay. Okay, so here the absurd robot is running. See this Spark. So yeah, absurd data to robot Spark is running on Spark. Yeah, so we just wait until the job is I'm sorry until the job is completed. Okay, maybe I will resume. Yeah, I will pause this first, and then we will I will go back after this after the job is success. Okay, so the you know all the task is complete successfully, and here's the timeline. Yeah, and yep, if we check on Spark, then finish. Okay, we are going to refresh here on AC and robot sensor. Refresh. Okay, okay, here we go. So each table is contain one machine type. Here is robot sensor. So here there is we can see all of the field, and here is the like moving average temperature. So it's still same, but when in the six record, the moving average is count the average uh on the on its uh, average its data with the six record before, and so on. Okay, think that's it. um okay, so lagi I don't know, so like okay, I think um, that's I think that's my ultimate data engineering uh, project or hands-on project. So yeah, thank you very much to watch this for watching this video. And if you are interested on me, you can hire me on Upwork, or you know yeah, on Upwork, or DM me on uh, LinkedIn. Bye bye.